Hello, and welcome to the Trepa Technologies Security Plus course. My name is Johnny Bandon, and I will be your instructor for this video series. This video will cover Domain 3.3 Secure Network Designs. Now let's get started. The first thing we're going to talk about is load balancing. Load balancing describes taking active TCP/UDP connections and distributing the load amongst different servers or services. For example, suppose we had a web server farm in our enterprise that handles client connections to our SharePoint portal. In that case, we can put in a load balancer application or hardware that will distribute the connections to different servers in the web server farm. How the load balancers decide to distribute this load is what we will discuss in the upcoming slides. In active load balancing will distribute the load across multiple online systems in no particular order, right? As far as just basic active. Then active-passive doesn't actually actively distribute the load. It uses a primary system to handle the connections, and then will rely on a secondary system if the primary goes down. Active/passive is not a deployment technique to handle daily load balancing. It is typically used in disaster recovery scenarios. Then there are multiple different scheduling techniques/algorithms that choose where traffic is sent to. So in our active, right, we're now going to have to do a scheduling technique or algorithm to choose how it's sent. IT administrators configure these load balancing algorithms to determine how traffic is to be routed behind the load balancer. Round robin sends connection requests to servers in a list, with each server receiving a portion of the traffic in time. Least connection sends traffic to the server with the least amount of active connections. So if server 1 has 10 connections, server 2 has 1. When 8 more connections are made, it's going to server 2. Agent-based load balancing will monitor their connection load and other factors to determine how traffic will be sent. So this is taking a more adaptive process. Least connection, like we described, if this is server 1, this is server 2, and there's a bunch going to server 1, our load balancer will start sending to server 2. And then round robin is just kind of in a list, load balancing as it pleases, right? A virtual IP address can be shared among different servers or network devices that users will send traffic to. Then the device with the virtual IP address is actually going to be the one that users connect to, right? So this is typically done on proxies or when you're using a first hop redundancy protocol like in networking. So for example, if we need to access those same SharePoint portals and we decide to implement a virtual IP address on our load balancer, the users will connect to that. Then this load balancer, or maybe even this proxy, will decide which server that user is going to connect to. So even in our DNS, right, server, this will be considered the IP address for the host name for our SharePoint portal. Maybe it's portal.com or whatever it is, right? And then we have persistence. Persistence is when a client has been load balanced to a server and then maintains that connection to the server through the session. Meaning that if a client's already made that connection and now we're requesting more information from that server, it's going to use that same server instead of being load balanced somewhere else. And now let's get into some network segmentation. A VLAN will logically segment sections of your network into different IP subnets by attaching a VLAN tag to each frame that designates traffic to be part of that certain VLAN. This allows network segmentation of traffic from layer 2 to 3. A VLAN is a typical deployment in larger enterprises to separate user traffic or different departments. And VLANs are essential for network architecture and security. Why? Because group policies can be implemented on a per subnet basis. So using VLANs, which also create those different broadcast domains and subnets, can be an essential part of your security architecture. And then this way, users in the R&D department and users in the accounting department can have different access permissions on your network, and you can plan around their different VLANs. A screened subnet is a perimeter network between the internet and intranet, It used to be called a DMZ or demilitarized zone. The intranet is going to be your organization's enterprise, and a screen subnet will have connection to both the outside world and your enterprise. And it'll have servers that should be able to be accessed from both, right? So for maybe a user sitting out here on the internet, they can access that web server, and users here can also access that web server, right? We call that a screened subnet. Then we have some more network segmentation, this one being a concept. So zero trust is a security policy, or really a mantra, that security administrators will implement so that anyone, whether they are inside or outside the organization, will be continuously authenticated and authorized when accessing network resources. Then some more network security designs. We have a VPN. So virtual private networks are a technology that will hide or mask your original packet's location, original IP address. VPNs are what we call a tunneling technology that allows users from outside the enterprise to connect to the inside network, or our enterprise, right, to access company resources. And there are many different ways to implement a VPN. And we're not talking about technology specific like IPsec or TLS. We're talking how to tunnel, right? So a split tunnel VPN will direct traffic in two ways. So if our user here has a split VPN, all non-essential or non-enterprise traffic will get sent out towards his internet connection. But any traffic that is corporate will be tunneled to his enterprise, right? That's what we call a split VPN. And then a full tunnel VPN is that doesn't matter what the traffic is, it'll all be sent through the VPN. So if we're in a full tunnel, if this user wants to go to google.com, instead of going directly here, it's going to use that tunnel straight to the corporate network and then back out. And then we have more types of VPNs. A remote access VPN is commonly used for roaming or traveling users that need to connect to the enterprise. A remote access VPN is only turned on when a user needs to access the enterprise, right? So this could be like an application on your home computer, like Cisco AnyConnect. I need to check my Exchange, my Outlook. Let me turn on my VPN, and boom, I have access to my company resources. And then a site-to-site VPN is a full tunnel VPN used to connect maybe like a spoke or a whole site back to the headquarters site, and that's where all the enterprise resources live. So on a site-to-site, let's say you have HQ router up here, and you may have your spoke routers down here, and they're connected via the internet, but they're creating site-to-site VPNs between each other. And then we have Ssl and Tls, which is also a VPN. So an SSL or TLS is a VPN solution because it's going to protect your IP packets during the client-server connections from host to web server. SSL and TLS will encrypt the data in transit and actually create that private connection for users connecting to a web server. TLS, the SSL, is lightweight, and anyone can use it as long as they add that extra S on their web sessions. And now let's go over something called network access control. Network access control is another security control / concept used to control what devices are allowed on the network and what resources they can access. NAC, or network access control, is often associated with 802.1x or port security. And with 802.1x, you're going to use Radius or TACX in a centralized server to authenticate and authorize network devices and endpoints. And then we have out-of-band management. Out-of-band management is a security concept or solution that allows users to manage their network devices by directly accessing them remotely. Now, what do we mean by this, right? So in this data stack, we have all of our networking devices. And instead of making individual SSH connections to them or going to their web GUIs, what we're going to do is reach out to a OOBM device connect to that OOBM device, and then that OOBM device, out of band management, will allow us to connect to all these. So instead of making direct connections, it's almost like putting a proxy in the middle, right? You connect to that OOBM device, say that's this right here, and that allows you then connection to the rest of your network devices. And now let's go over port security. So port security is a layer 2 technology that protects our network switches from layer 2 network attacks. The Security Plus exam describes port security as any layer 2 protection, like let's say spanning tree protocol. But for many of you in a networking background, we know port security will either refer to 802.1x, right? Or actual port security configuration we put on our switches, which manage how many MAC addresses can be ingressed. We will talk about layer 2 technologies under port security for the Security Plus exam. So this will just be a umbrella term, right? When talking about port security. So spanning tree protocol is a layer 2 protocol that prevents what we call broadcast storms in our switched network. STP or spanning tree protocol prevents broadcast storms by selecting a root switch that all switches will forward frames to. And any redundant connections in the switch network will be cut off by placing one port into a disabled state. So STP, right, has our loop prevention. And it really does this because, not to get too deep into switching concepts, because this is not a CCNA exam, when we send a broadcast frame out from a switch and we have a network like this, that broadcast frame is essentially going to be looped. And it's going to keep going because broadcast it sends everywhere, right? And this will cause our CPU to be throttled, and then it's going to cause our switches to no longer be functioning correctly. We call that a broadcast storm. Well, the loop prevention method or protocol we have is STP, and that's going to cut off one of these redundant ports and not allow those broadcasts to circulate like that. And STP is another concept that we could really deep dive into, but we won't because we just need to know what it does for the Security Plus exam. It prevents loops and broadcast storms. Now let's go over DHCP. So DHCP and snooping, right? So we know DHCP is the dynamic allocation of IP addresses, but we also want to prevent rogue DHCP servers from being on our network and handing out IPs. So the technology we have to prevent that is DHCP snooping. DHCP snooping will prevent rogue DHCP servers from handing out IP addresses to clients. When a rogue DHCP server is on the network, it can give out a fake default gateway and have users send old traffic to that malicious default gateway. A threat actor can then perform packet captures on that user's data. So what DHCP snooping does is it actually prevents that by doing some sort of authentication in the DHCP process from users to the real DHCP server, right? So it's going to drop messages from any DHCP server that are not on the list of trusted servers. And then we have MAC filtering, or immediate access control filtering, right? Your MAC addresses. This prevents a frame flooding attack by only allowing a manually specific MAC addresses that you configured to be allowed on your switches. So in this photo right here, this is actually a Cisco switch that's doing what we call switch port security. And this is specifying on that switch port of that switch that only this MAC address is allowed, and there's only a maximum of 2 MAC addresses allowed on the port. And if more than 2 MAC addresses get sent to that port, it's going to put it in what we call an error disabled mode. And that switch port will no longer be able to forward frames. Next, let's go over some network appliances. A jump server is a secure and monitored system that we can use in our enterprise to allow remote sessions into our network. A jump server will typically sit between different networks or on a screened subnet that will give us access to our internal enterprise from the outside. We can implement a jump server instead of a VPN when accessing our network devices. Jump servers can also host all of our admin tools like Active Directory users and computers, terminal emulators, or other admin tools that we can use instead of having all those admin tools on our local workstations. And then we have proxy servers. Proxy servers are an in-between for clients connecting to web servers. A user will connect to the proxy, and then that proxy will connect the user to the actual web server or resource they wanted to connect to. Some more network appliances. We have Nids. So we've talked about HIDs and HIPs. Now let's go over Nids and Nips, which is the network version of that. A Nids or Nips device can install inline directly on the traffic path to perform detection or prevention. A Nids will only detect and monitor and alert the administrator to a malicious event or incident, or to alert deviations from user baselines. So you can implement some sort of AI or user behavior analysis on your Nids. And then a NIPS can also perform detection, but its primary purpose is to prevent a malicious incident from happening. So NIPS is going to block those threats, right? Some more network appliances. We have our hardware security modules. A hardware security module is a network appliance used to manage cryptographic keys in your enterprise. So an HSM will offload the load from CPU, right? And that instead take that burden, right? So an HSM will actually store and create your crypto keys instead of your computer doing it. Then we have some more network appliances like firewalls. So a web application firewall protects and prevents security threats over an HTTP conversation. These WAFs, or web application firewalls, will protect against common attacks like cross-site scripting or SQL injection attacks. And it will actually prevent HTTP connections from happening when it notices something malicious. Now let's go over a UTM. A Unified Threat Management System is a term to describe a device that will provide defense in depth for your enterprise. So that UTM provides defense in depth, all in one device. A UTM will combine multiple different security tools into one device, and that UTM can sit inline or on the traffic flow path in your network, right? So if we were to draw it out, that UTM can sit in front of that router, and even behind it, which I don't recommend, right? And this can do all the things that these other devices can do. It can do routing, it can do IPS, email filtering, it can be a VPN, it could be your antivirus solution, it could also be your firewall, your next generation firewall. And the benefit of a UTM is it can be a lot more cost effective for an enterprise. However, now you're putting all your security eggs into one basket by creating a single point of failure. So typical UTM solutions may combine 1, 2, or 3 different security appliances, but you usually don't want to do everything, right? Because if that thing fails, then you're just open for business, right? And then some more firewalls. So stateless firewalls are the most basic type of firewalls, and they're going to filter packets based on IP addresses, ports, and protocols. Stateless firewalls will filter traffic based on permit and deny statements, or ACLs, we like to call them, access control lists. And these ACLs will have what we call ACEs, access control entries, that will permit or deny based on IP/port or protocol. A stateful firewall will filter based on the state or conversation of traffic between systems. So in a stateful firewall, you may configure it so that only from the inside to outside will allow TCP connections. Then we have some more network technologies. Let's go over NAT. So network address translation converts private IPv4 addresses into public IPv4 addresses, which are routable on the internet. NAT preserves public IPv4 addresses, and a NAT gateway is any device that sits on the perimeter of your network that will perform the private to public translation. Now, typically, this is going to be a router or firewall, and NAT has different modes or implementations. The only one you need to really worry about, and this necessarily isn't for the exam, is PAT, which is port address translation, which will allow many private IP addresses to be converted into a singular public IP address. This is exactly what your home routers will do. PAT is the standard implementation you will see in networks. And then we have content slash URL filtering, which will block traffic based on content rules instead of IP addresses or protocols. We kind of talked about this in our next generation firewalls. Content slash URL filtering can be very granular in how it works. Next generation firewalls that are doing this layer 7 inspection or this content inspection will permit or deny based on the type of traffic. And then let's go over our ACLs, our access control lists. These are the set of rules that define traffic based on IP or protocols. ACLs are the basis of stateless firewalls, and they're the permit and deny rules in a firewall. And then we have QoS, or quality of service. This is a technology used in networking to ensure an app or service has the proper priority for transiting the network. So you may see a typical QoS implementation that sometimes just standard is for VoIP traffic. They'll usually get priority because VoIP traffic needs a certain amount of throughput and bandwidth to be able to complete phone calls. Then the last thing we're going to talk about is FIM, or File Integrity Monitoring. FIM ensures that files are not altered or changed by an unauthorized person or party. FIM can monitor and notify administrators when a system's file has been changed, or to restore a file, or FIM can restore a file to its original contents if it is backed up properly and configured to do the restoration. So FIM is a great tool to verify integrity of files, right? To let you know if something's been changed by an unauthorized personnel. Now, when not to do FIM? If you're working on a document and collaborating with different departments, probably not best to implement FIM on that file. But let's say for your System 32 files that should never change on your Windows machine, maybe you should implement FIM. So we know if some virus got a hold of here and changed something in our system. All right, so that is it for this video. I know it was another long one. So I want to thank you for viewing, and stay tuned for our next video where we will discuss Domain 3.4 Secure Wireless Networks. Thank you.